Okay, problem 8. Let's roll this down. Coin is tossed 100 times. True or false? Okay, so we have a coin. It's tossed 100 times. Let's see if we can understand this. The expected value for the number of heads is 50. Okay. Okay, so we have to answer each one of these. The expected value for the number of heads is 50, and we can say that is true. Probability of getting one head is 1/2. I should probably do it here. Probability of one head is 1/2 times the number of tosses, 100, equals 50. Okay, B. Expected value for the number of heads is 50. Give or take 5 or so. Well, the expected value, this one is false. Because the expected value is what we did right up here. It's the average, or it's the probability of one event times the number of rolls, or the average of the draws, or the average of one event times the number of rolls. In this case, the average is 0 is you don't get a heads, 1 is if you get a heads, and so the average between 0 and 1 is 0.5. So maybe I said that wrong when I said probability. It's the average of the two events times the number of rolls. Okay, the number of heads will be 50. False. Very rarely. We don't know if it will be 50. It might actually be 50 one time, but probably not twice in a row. The chances are the expected value is 50, but it won't necessarily be 50. D. The number of heads will be around 50, give or take 5 or so. This one I'd say is true. The give or take 5 or so, that's probably your standard error. And our standard error is equal to square root the square root of the tosses, or the square root of 100 times our standard deviation, which on a coin is 1/2. There's only 0 or 1. Standard deviation is 1/2. Times the square root of 100 is 10, and so that equals 10 times 1/2 is equal to 5. So 5 is our standard error, and we know that our expected value is 50, so we can say that it's going to be around 50, around our expected value, give or take a standard error or so. So yeah, we can say that's true. Should we go ahead and tack on 9 on this problem? Let's go ahead and do it. Number 9. 100 draws are made at random with replacement from a box with 99 tickets marked 0 and 1 ticket marked 1. So we have this box, right? And you have 99 zeros, and then you have 1 1 over there. 100 draws. You're going to draw 100 times random with replacement. True or false? Explain. Okay, so A. The sum will be around 1, give or take 1 or so. Well, so if you take the average, if you add up 99 zeros and 1 ones, the sum of those is going to be 1 divided by 100 numbers. Average is going to be that would be 0.01 is the average. The standard deviation And basically the standard deviation, if we were to calculate it by hand, I won't plug all those into my calculator, it would take too long. Standard deviation is the square root of the sum of the variances. So basically the variance from 0 to 0.01 is what our expected is 0.01. So 0.01, okay, that's going to be squared. Okay, and we're going to do that 99 times. Times 99. Okay, and then we're going to add that to the 1 minus 0.01, which is 0.09 as a variance, squared. We're going to divide that whole thing by 100 numbers. And so our standard deviation is going to be, let's see what that looks like. We got 0.01 squared times 99. Okay, then we have 0.09 squared. We're going to add that to the 0.0099 plus divided by 100. Okay. We're going to take the square root of 1.8 e. Where's our e? E to the negative 4. 0.013. Okay, 0.013 is our standard deviation. And so the sum will be around 1. Okay, the sum is going to be the average times the number of draws. So it's going to be 0.01 times 100. Maybe I got sidetracked there. 0.01 times 100. And that is going to equal 1 with give or take 1 or so. And it's really going to give or take 0.01 plus or minus 0.013 or so. So that's going to be false. Unless, of course, I screwed up. Okay. B. There is about a 68% chance that the sum will be in the range of 0 to 2. So if we draw our curve here, okay, and this is our expected value is 1. We saw that in problem 1. If we standardize this, that middle is 0. And basically, if we want to go from 0 to 2 and find out how many standard deviations that is, so the z, first z is 0 is equal to 0 minus 1 divided by you know, this was a standard deviation, this wasn't the standard error. Standard error for problem 1 is equal to square root of 100 times the standard deviation of 0.013 is equal to 10 times 0.013 is equal to 0.13. So this is actually 0.13, still false. 0.13 3. So if you have minus 1 divided by 0.13, we're equal to minus 7.69. That's not right. You know, I'm going to scratch this problem. Let me do it all over in the next video. This one's getting too long.